All right, so hi everyone. My name is Matt Dixon. I'm a meteorologist in the UK Ag Weather Center. First off, I want to say that I'm recording this video on February 17th, and I hope everyone has made it through this stretch of winter weather all right. It's definitely had its fair share of impacts, especially across southeastern Kentucky, as many are still without power. This has definitely been a winter to remember, as most of our winters recently have been running mild. If you're not a fan of the cold, outlooks do hint at above normal temperatures for the end of February and start of March. But moving along, I started at UK back in 2012, unfortunately in early July when Kentucky was experiencing the worst drought in years. Since that major drought in 2012, we've been trending to a wetter and warmer climate here in the Bluegrass State. In this presentation, I'm going to talk about some of those climate trends we are seeing in Kentucky and hope to prompt some thoughts on how these changes could impact your management and production practices on the farm moving forward. So looking at a long range forecast right now, they are lacking in accuracy at times, but something that is not lacking is climate data across the state, which gives us a way to see any climate trends being seen across the Commonwealth. I gave a similar presentation at the winter wheat meeting in early January, and I will repeat some of the information for folks that did not attend that meeting. But unlike that one, I'm going to focus this talk to the irrigation community and the climate trends we are primarily seeing during the growing season running from April through October and for the row crops of corn and beans. The two elements in the weather that play the largest factor in determining the success or failure of these crops and the associated needs for irrigation is precipitation and temperatures. So starting off, rainfall is quite abundant across Kentucky compared to many other states. In fact, the state averages over 47 inches per year based on the 81 through 2010 climate normals. I'm going to be referring to this word normal quite a bit throughout the presentation. What is a climate normal? It is essentially the average weather conditions for a particular location over a 30-year period. In this instance, I have a map of Kentucky where I show the normal annual and seasonal precip for locations across the state. These normals give us something to compare our current weather to, whether it's been above, below, or near normal. These normals also give us an idea of how to manage our farms. As I'll refer to later in the presentation, and just as an example for now, normals tell us our average last freeze date in Lexington is April 14th. They tell us how warm or cold it typically is at this time of the year. Just for instance, normals tell us the average highs today on February 17th in Kentucky lie in the middle 40s to low 50s. So compared to normal, we are running well below average for this time of year. So looking at the map, normal annual precipitation across the state ranges from around 43 inches across the northern bluegrass to closer to 50 across the southern fringes of the state. These values are based on the 81 through 2010 climate normals, and taking into account changes to our climate, these normals are updated every 10 years. The next set of normals are based on the years 1991 through 2020. These should be coming out around the middle of this upcoming summer, around July. Throughout the presentation, I'm going to show you how our climate has been trending in relation to these normals. So we'll start out with a look at precipitation. Each blue bar shows the annual average precipitation seen across the state. You can see the ups and the downs through the past 100 plus years, but ultimately I want to direct your attention to the last several years on the right side of the graph. I've included a trend line on the graph, and as you can see, we are on the upward trajectory recently with 6 straight years of above normal precip here in the Bluegrass State. So in comparison to the past 125 plus years, how wet has it been recently? Well, this is a list of the top 10 wettest years on record for Kentucky with data going back to 1895. I've highlighted the years within the last decade that show up in the top 10. 5 years are included. 2011 tops the list with a state average of 64.35 inches that year. 2018 is not too far behind at just under 64. 2019, 2015, and now 2020 sits in the top 10 also. Just last year, the state averaged 57.87 inches. We compare these averages to normal, and we've been running roughly 10 to 16 plus inches above normal over those years. So bottom line, it's been trending very wet in Kentucky on a yearly basis. So how about temperatures? In this graph, I also plotted the average annual temperature of the state and added a trend line over the past 125 years. What do you see? The start of the 1900s features some cooler years across the Commonwealth, followed by increased temperatures in the 1930s. We then ran cooler with the dip in the trend line peak in the late 1960s and early 70s. Since then, we've been on quite the uphill climb. Something Chad pointed out in the winter wheat meeting, the peak in the trend line we are currently seeing is actually higher than the one we saw with the very warm years in the 1930s, which in the past we've associated with some of our warmest years on record. So how warm has it been recently? Looking at the top 10 data, again, 4 years out of the past decade, placed in the top 10 warmest years we've seen over this record, going back to 1895. The drought year 2012 sits there at number 2, with 2016-17 not too far behind. 2019 number 8. Even though you don't see 2020 on the chart, we did have another warm year last year, with the state average coming in at 57.1 degrees, good for number 17 on record. Something that I want to point out again, we are surpassing some of those years in the 1930s, which show up on this chart at number 5, 8, and 10. So now I'm going to combine the two variables of precip and temperatures to show you a trend we've been seeing through the years. In the upcoming several slides, I've included several time series scatter plots for primarily the growing season across Kentucky. In these plots, I take the average temperature and precipitation total for the state over a specific time period and plot the year on the graph. In the case of 2020 on this slide, we averaged a little over 57 degrees and almost 58 inches in precipitation last year. If you take those numbers on the X and Y axis, temperature on the X, precip on the Y, and draw a line across the graph from each, the XY coordinates meet up in the upper right portion of the chart with the year highlighted in red. I include every year going back to 1981. I then divided the data into 4 boxes separated according to the average temperature and precipitation, in this case on the annual side. Now looking at the data, any years in the box in the upper right would be years that saw above normal precip and temperatures. The top left would be years with above normal precip and below normal temperatures. Bottom left, years with below normal temps and precip, and the bottom right, below normal precip and above normal temperatures. So lastly, I then highlighted the past 5 years in red. What trends do you see on the graph? On the annual scale, the past 5 years all show in the upper right-hand box for above normal precip and temperatures. So now I'm going to take this graph, and unlike the winter wheat meeting where I showed the date by season, I'm going to now show the data for the growing season as a whole. What do you see? For the most part, we continue to see the previous 5 years in that upper right-hand corner for above normal precip and temperatures. Unlike the annual data where we saw above normal temperatures for the year, we actually saw slightly below normal temperatures during the 2020 growing season. So how about planting season in Kentucky, April and May? This is the one place where I saw precipitation running closer to the average normals for 81 through 2010. Every year over the past 5 is pretty close to that blue line showing average precip. 4 of the 5 years are running near to above normal for temperatures. The one exception was again 2020, which everyone remembers contained a couple late freezes for the state in the middle of April and start of May last year. More on this trend later. So in the next 2 graphs, I divide the summer into 2 different sections to show the trends over the first half of summer and the second half, the main irrigation period for the year. You see the trend continue for the months of June and July. The past 5 years have all ran above normal in precip over those 2 months, and outside of 2017, the same can be said for temperatures. While I'm on the point, I did some preliminary research on the number of days above 90 degrees for some locations across Kentucky. And while we have been trending warmer, I didn't see anything significant that we've been seeing more extreme heat across Kentucky. I also looked at some data corresponding to the number of days we saw extreme rainfall, but once again, despite years recently showing above normal rainfall, I'm not seeing a clear trend that we are seeing more extreme rainfall events. So saying that, rainfall can be sporadic spatially, so I plan on looking more into both these subjects in the future. So moving on, you see that same trend continue when I combine the months of July and August. 2016 sits quite a ways up there in the upper right-hand corner, showing that year was one of the wettest and warmest years the state has seen since 1981. Lastly, I wanted to include a look at the harvest season. While the state has seen above normal temperatures each of the past 5 years, precip has been a little bit more sporadic. While most of the events lie in the upper right-hand box again, 2017, 2019, and 2020 lie closer to the precip average for that time of year. 2018 was very wet, while 2016 you see down at the bottom right due to the drought we saw that year in September when the state only averaged 22 hundredths of an inch. So moving ahead, I now want to take a look at drought in Kentucky. This here in Kentucky, and every farmer knows, Mother Nature tosses some curveballs our way. We've seen that the past couple of weeks with a number of winter storms working through the area, and it doesn't change much during the growing season. One of those curveballs can come in the form of drought. When looking at ag, it's all about that timely rainfall throughout the growing season. We all would prefer a nice 1 inch, gentle, soaking rainfall event every week of the growing season, but it never works that way in our neck of the woods. Sometimes we are fighting torrential rainfall events and flooded fields, while other times, like 2012, it was hard to come across a tenth of an inch at times. We need a way for our crops to see a sufficient and timely water supply, and irrigation has been our answer. In recent years, we've seen some wet years here in Kentucky, saying that we still do have our fair share of abnormally dry periods that will occur during the growing season. There are two different kinds of drought: agricultural drought and hydrological drought. Ag would be the short-term drought deficits, and hydrological would be the long-term deficits where you start seeing water supply issues. As you all know, it doesn't take very long during the summer season to start seeing abnormally dry conditions if we don't see any rain. The U.S. Drought Monitor is an organization out of the University of Nebraska and Lincoln that was set up to monitor drought conditions across the United States. They have a map across the area that is released on a weekly basis showing the locations and intensity of drought across the United States. I put the link at the bottom if you're interested in looking at this map. All in all, you can see that Kentucky is in the clear right now. The worst of the drought is across the western half of the U.S. and diminishes as you move east. So what do all these colors mean? They are based on impacts being felt across the state at any particular time, whether that is short or long-term drought. So in this slide, I listed the impacts typically associated with each category in Kentucky. D0 or abnormally dry conditions in the yellow is your short-term drought impacts that are typically first to show up when it starts getting dry outside. As you can see, D0 entails lawns and vegetation starting to get brown, and crops, pastures starting to show mild stress. Intensity levels get worse from there. D1 is your moderate drought and tan, D2 is severe, D3 is extreme, and D4 is exceptional down there in the dark red. Over half the state dipped into the severe category in October 2019 following the very dry September that year. We were seeing many of the impacts described on this page, especially low hay yields and the need of supplemental hay and water for livestock. D3 and D4 played a factor in 2012, especially across Western Kentucky when long-term drought was setting in across the area and leading to supply issues. If I remember correctly that year, I think the Mississippi River was close to shutting down around our area also because of low water levels. So extreme problems in 2012. Anyways, now that we have an idea of the categories, I take you to the next slide where I show a drought time series over the past decade. As you can see, droughts are somewhat short-lived for us. Many are now calling these flash droughts. You can see these in all those spikes of yellow and tan, the abnormally dry category and moderate drought. We've really only had a couple more intense droughts since 2012, one occurring in late 2016, the other in late 2019, which is typically our dry season here in Kentucky. But by and large, they were short-lived again. I want you to see that despite us trending wetter over the past several years, we still have plenty of periods containing abnormally dry conditions. They may not last long, but they are there. So this is highlighted in the following graph. I pulled data from the U.S. Drought Monitor website to find the number of weeks each year that at least 20% of each climate division across the state listed below is consumed by an area of abnormally dry conditions during the growing season. Those columns peak in 2000, 2008, and again in 2012 with the severe droughts those years. But looking outside of those years, we do have some like 2003, 04, 17, 18, and even 20, where dry conditions were not a problem. But going with my last statement, even in the midst of a wet period, we still had several periods of abnormally dry conditions in 2019. So bottom line, irrigation has been needed in the past and will continue to be needed in the future despite a trend to wetter conditions. So next I want to take a look at frost and freezing temperatures that can impact the start and end of the growing season. Just to start off, I talked about this in the winter wheat meeting. This is a map from the Kentucky Mesonet showing low temperatures on the morning of May 9th last year. Much central Kentucky and points east had lows dip into the middle to upper 20s that night, several hours below freezing. Chad can correct me after this presentation if I'm wrong, but I believe most of Kentucky corn squeaked through this event with the growing point below the surface. Anyways, I want to point out um, that this event in May was rare. In the end, freezes are rare. May freezes are rare here in Kentucky, plain and simple, especially when looking at temperatures in the 20s. On the chart, I listed the last date of spring freeze for 5 locations across the state over the past couple decades. I highlighted and read the events that occurred in May. You can see that they are very few. In Lexington, you have to go back to 2005 to find the last event prior to 2020. Bowling Green and Paducah still haven't seen a freeze in May over that time span. They both were above freezing for that May event last year. It was a first for Jackson, Kentucky in 2020, and looking at Cincinnati has happened multiple times in the past with their higher latitude. Ultimately, in the end, May freezes, especially those in the 20s, are rare for most of the state. Looking at frost freeze normals, this chart is available in the extension pub I listed below. When looking at this chart, I tend to focus on the column with 50%. This would be the average day each of these locations see their last freeze in spring or first freeze in fall. Just as an example, if I look at Lexington, our average first freeze occurs on October 27th, while our average last freeze in spring occurs on April 14th. Also included is the earliest and latest freezes for both seasons, in addition to a couple categories of 10 and 90%. When using these two categories, just as an example, in Bowling Green and looking at spring frost data on the right, only 10% of the time will the last freeze occur after April 25th. Now, how are these frost freeze normals changing over the years? In the top chart, I listed the average data first freeze for the locations listed. But to show you the change in normals, I've included the data from the 1971 through 2000 normals, the current normals of 81 through 2010, and I went ahead and used a program with the Midwestern Regional Climate Center to estimate the new 1991 through 2020 normals that will come out this year. In the top chart, our climate is shifting our average first freeze a little later. For some, it's not much of a change, but looking at Bowling Green, for instance, the average first freeze date went from October 23rd in the 71 to 2000 normals to October 29th with the 91 through 2020 normals, shifted about a week later. The same can be said about London, but in general, all the stations are seeing their average first freeze a little later in the fall season. The second chart examines spring data. What do we see here? There's a trend that our last average freeze is occurring earlier in the year. For Lexington, it shifted from April 15th in the 71 through 2000 normals to April 9th in the latest set of normals. Again, about a week difference. Cincinnati and Bowling Green saw similar outcomes. So what does this mean? For the most part, our growing season is trending longer in Kentucky. In the last chart, I listed the average freeze-free period for each station. Just from 71 to 2000 to 91 to 20, we are tacking on quite a few more days to the growing season. It's pretty significant for some locations like Bowling Green that went from 195 days to 208 days. Louisville went from 205 to 217. So all in all, our warmer climate is extending the growing season. So lastly, I wanted to bring your attention to some tools offered by the UK Ag Weather Center that might help you in your management and production practices. First is the Point Ag Forecast. This has been around for quite some time and can be accessed easiest by the blue county map on our front page at weather.uky.edu. Everything's on mobile too and is free to use on our website. In this product, the goal was to give the farmer a more descriptive weather forecast moving forward with more information than what you would see maybe by looking at that 6 p.m. newscast. So all forecast data comes from the National Weather Service and is constantly being updated by their forecasters to provide the best forecast at that time. In this point ag forecast, we took that info and broke it down into 3-hour increments to give farmers a better look at such things as the start and end time of precip, accumulations, wind speeds for spray applications, precip coverage, temperatures, you name it. We then added some other rows at the bottom for the ag sector based on the forecast data above. While this tool is available for everyone in Kentucky, if we have anyone on the webinar from outside Kentucky, it is also available across the nation. So specifically for this webinar, I wanted to include this irrigation manager tool set. We created this tool following the 2012 drought and gives users a, a tool to see how much evapotranspiration has occurred at any point in the year and compare that to the accumulated precip at a gauge in your county, which in turn calculates an estimated water surplus or deficit over that specific period. In the chart below, I pulled data from Caldwell County for July 1st through the 8th last year. In the end, the location had a deficit of 0.64 inches at the end of the period. Just a little bit more information on this. Evapotranspiration, if you're not familiar with it, is a general way to see how much water and moisture your farm is losing on a daily basis based on data from the closest weather station. Right now, we use the Penman-Monteith equation to estimate evapotranspiration and currently only use a grass reference. In the future, I plan to add different coefficients to relate to other crop surfaces. So lastly is the county summaries tool where climate data can be accessed for your location at different timescales. In this chart, I take a look at the current climate data out of Lexington. Looking at the chart over the past 7 days, this location has averaged 1.46 inches, which is 65 hundredths of an inch above normal, just in one example. So we include some data from the irrigation manager at the end of the chart in addition to growing degree day and insect degree day estimates below. So that is where I'm going to conclude. If you have any questions, feel free to reach out at my email list on the slide. As a side note, and if you're interested, a climate webinar is hosted by the Kentucky Climate Center on a monthly basis on the first Thursday of each month. Please feel free to join, share it with others. Together with the state climatologist, we discuss the current climate conditions across the state, impacts related to those climate conditions in agriculture and water supplies, and then take a look at climate outlooks moving forward. I've included a few email addresses there on the slide to contact for getting signed up for the webinar. Otherwise, I'll also share it on my Twitter feed when the date gets closer. You can find that on our homepage at weather.uky.edu. So our next one will take place on March 4th at 2 p.m. Eastern Standard Time, 1 p.m. Central. So with that, I'm going to close up, and I wish everyone the best of luck in the upcoming growing season.